Alkenes exhibit structural isomerism. Consider butene. The three different isomers are but1ene, but2ene and 2-methyl-prop-1ene. Now consider but1ene and but2ene. The difference in structure is due to the difference in the position of the double bond. So but1ene and but2ene are position isomers. Now consider but1ene and 2-methyl-prop-1ene or but2ene and 2-methyl-prop-1ene. The difference in structure is due to the difference in the number of carbon atoms forming the longest chain. So but1ene and 2-methyl-prop-1ene are chain isomers. Similarly, but2ene and 2-methyl-prop-1ene are chain isomers. Thus, alkenes exhibit both position isomerism and chain isomerism. Alkenes also exhibit geometrical isomerism known as cis-trans isomerism. Consider an alkene CXY double bond CXY. Each carbon has two different atoms X and Y attached to it. We can show similar atoms on the same side of the double bond, or similar atoms or groups can be shown on opposite sides of the double bond. So if similar atoms are shown on the same side of the double bond, we get the cis isomer, and if similar atoms or groups are shown on opposite sides of the double bond, we get the trans isomer. Now consider but2ene, which is CH3CH double bond CH CH3. Each carbon has one methyl group and hydrogen attached to it. So we may show the hydrogen atoms on the same side of the double bond, or we may show the hydrogen atoms on opposite sides of the double bond. If similar groups are shown on the same side of the double bond, we get cis-but2ene, and if similar groups are shown on opposite sides of the double bond, we get the trans isomer. Now if we consider cis-but2ene and trans-but2ene, the dipole moment is found to be 0 for trans-but2ene, whereas cis-but2ene has a definite dipole moment and it is equal to 0.33 dBunits. Let us now discuss various methods of preparation of alkenes. First method, from alkynes. An alkyne undergoes hydrogenation reaction, that is addition of hydrogen in the presence of pelletized charcoal to give cis-alkene. Whereas an alkyne undergoes hydrogenation reaction in the presence of sodium in liquid ammonia to give trans-alkene. Now consider ethine CH triple bond CH. Addition of hydrogen in the presence of pelletized charcoal gives ethene. Now consider propyne. Addition of hydrogen to propyne in the presence of pelletized charcoal gives propane. Another method of preparation, it is from alkyl halides. The method is known as beta elimination or dehydrohalogenation. Now consider alkyl halide CH3CH2X. When an alkyl halide is treated with alcoholic potassium hydroxide, along with the halogen atom, hydrogen from beta carbon gets eliminated. It results in the formation of carbon-carbon double bond between the alpha and the beta carbon atoms. Since removal of HX takes place, the reaction is known as dehydrohalogenation. The product obtained in this case is ethene CH2 double bond CH2. Alkenes can also be prepared from vicinal dihalides by dehalogenation. Consider CH2Br CH2Br. The compound is 1,2-dibromoethane. When treated with zinc, dehalogenation takes place. It results in the formation of ethene CH2 double bond CH2 and zinc bromide. Now consider another vicinal dihalide CH3CHBr CH2Br, which is 1,2-dibromopropane. When treated with zinc, dehalogenation takes place and it gives the alkene propene CH3CH double bond CH2 along with ZnBr2. CH2Br is a vicinal dihalide. It is because the two halogen atoms are with adjacent carbon atoms. So alkenes can also be prepared from vicinal dihalides by dehalogenation.